So the question asks the point 2, 0, negative 3 lies on a sphere centered at 1, 1, 1. What is the radius of the sphere? So let's draw the sphere. The sphere is at 2, 0, negative 3. So x, y, z, and 2. So 0, 2, 0, and negative 3, somewhere around here. So I'm guessing like around here. This is the center, and we draw the circle. And since we're given it's the sphere, we can use the sphere equation. So if you write the sphere equation, it's x minus a squared plus y minus b squared plus c minus c squared equals r squared, which r squared is the radius squared. And then a comma b comma c is the center. Since we're given center is at 1, 1, we can write it as 1, 1. And you can rewrite this as x minus 1 squared plus y minus 1 squared plus c minus 1 squared is r squared. And now we're given the point is at 2, 0, negative 3. So let's plug it in. 2 minus 1 squared plus 0 minus 1 squared plus negative 3 minus 1 squared equals r squared. So then the r squared will be 1 squared plus 1 squared plus negative 4 squared. So it will be r squared equals 18. Then r is 3 square root of 2. So the answer is E. So this question asks which of these three-dimensional vector is not a unit vector. So let's go over the definition of unit vector. The definition of unit vector is any vector with magnitude of 1. So in order to find the unit vector, what you do is square the values in the each of I, j, k component and then square root of it. So let's try A. A is 0, 4 over 5, 3 over 5. So 0 squared plus 4 over 5 squared plus 3 over 5 squared, square root of it. This will give you 25 over 25 square root, and then it will be just 1. So it's not A, since it is a unit vector. Let's try B. B is 2 over 7, negative 3 over 7, 3 over 6 over 7. So if you square the square root of 2 over 7 squared plus negative 3 over 7 squared plus 6 over 7 squared. This will give you 49 over 49, which is 1. So this is a unit vector, so not B. C is a J, vector J. So this will be just written as 0, 1, 0. So this is just 1. So it's not C. Let's try D. D can be written as 1 over square root of 3, 1 over square root of 3, 1 over square root of 3. So if you do the square root of 1 over square root of 3 squared plus 1 over square root of 3 squared plus 1 over 3 square root of 3 squared, then it will give you square root of 3 over 3, which is 1. So it's not D. So E, cosine pi over 10, 0 sine pi over 10. So if you square root of it, then cosine pi over 10 squared plus 0 squared plus sine pi over 10 squared. Since cosine squared, we know that cosine squared theta plus sine squared theta is 1. So it will be 1. Cosine pi over 10 squared plus sine pi over 10 squared will be 1 plus 0, which is 1. So it's not E. So let's look at F. F is 1 over 3, 1 over 3, 1 over 3. If you square root of all the values, 1 over 3 squared plus 1 over 3 squared plus 1 over 3 squared inside of square root, which will give you 3 over 9. This is just square root of 3 over 3. This is not equal to 1, so this is not a unit vector. So the question asks B equals -1, -2, and W equals 2, 3. So to find projection W onto B. So in order to find projection of W onto B, this will be written as W times B over B times B times B. Let's write 2, 3 times -1, -2, -1, -2 times -1, -2 times -1, -2. This will be written as 1 plus 4 for the denominator, -2, -6 for the denominator, and -1, -2, which can be simplified as -8 over 5, -1, -2, which is 8 over 5, 16 over 5. So the answer is B. So the question asks the 3.0, 0, 0, 1, 1, 1, and a, 7.5 from the vertices of a triangle with area square root of 6 over 2. Select the value of a from the following choices. So in order to find the triangle area, what you do is you put a vector and then b vector, and then you do 1 over half times a cross multiply b, and then find the magnitude of it. So this is equal to square root of 6 over 2. Okay, so let's try putting 0, 0, here, and 1, 1, 1, and then put a, 7, 5 here. So if you try to find the vector a, it would be 1, 1, 1, minus 0, 0, 0, which is 1, 1, 1. There we go. And then we want to find vector b, which can be written as a, 7, 5 minus 0, 0, 0, which is a, 7, 5. Okay, so if you cross multiply a and b vector, I, j, k, 1, 1, 1, a, 7, 5. I will be 1, 7, 1, 5, 5i minus 1a, 1, 5, j plus 1, 1a, 7, k. If you find the determinant, it will be -2i minus 5 minus aj plus 7 minus ak. And we want to find the magnitude of it. So what we do is square the values, -2 squared plus a minus 5 squared plus, 5 minus a squared. 5 minus a squared plus 7 minus a squared, which will be 4 plus a squared minus 10a plus 25 plus a squared minus 14a plus 49. This will be equal to 2a squared and then 24a, and then it will be plus 78. Did I do this right? 49, 25, and then 74. Right, it is 78. Okay. So, square root of 2a squared minus 24a plus 78 over 2 should equal to square root of 6 over 2. So, this means 2a squared minus 24a plus 78 should equal to 6. 2a squared minus 24a plus 72 equals 0, which is a squared minus 12a plus 36 equals to 0. This will eventually give you a minus 6 squared equals 0. So a is equal to 6. So the answer is A. So this question asks, suppose B cross multiply W equals 3, and then tangent theta equals square root of 3. Find B dot W. Okay, so B cross multiply W magnitude, which can be written as B magnitude W magnitude, and then sine theta. Then B dot W dot product can be written as B magnitude W magnitude and cosine theta. And we are given tangent theta equals square root of 3. Tangent theta is same as sine theta over cosine theta. So we seek sine theta and cosine theta. So what we do is divide those equations. B cross multiply W magnitude over B dot W equals B W magnitude sine theta over B W magnitude cosine theta. B W will be cancelled out, and then sine theta over cosine theta can be written as tangent theta. Then b cross multiply w can be written as 3. Magnitude of that will be equal to 3 because we are given. And then we know b dot w, which tangent theta equals 3 over b dot w equals square root of 3. So we can write b dot w as square root of 3 times b dot w equals 3. So b dot w equals 3 over square root of 3, which can be written as square root of 3. So the answer is C. So the question is find the area of the region bounded by the curves y equals e to the x and y equals e to negative x and x equals 1. Let's draw the curve, okay? Y equals e to the x and then y equals e to the negative x. Okay, and then x equals 1. Okay, so this is the region. And in order to find the region bounded by those curves, you subtract the curves in between. So, okay, there we go. So this much is y equals e to the x, and this much is y equals e to the negative x. So what you do in here is subtract those like differences. So e to the x minus e to the negative x dx, and this is from 0 to 1. So if you integrate this, this will be e to the x plus e to the negative x 0 to 1. E plus e negative 1 minus e 0 plus e 0. So e plus e negative 1 minus 2. So e plus 1 over e minus 2. This can be written as e squared plus 1 minus 2e over e. And this is just e minus 1 squared over e. So the answer is D. So the question asks find the volume of the solid whose base is the region bounded by the curve. So in order to find the volume, we need to find the area. So the volume is area like integration. So let's draw it first. So the isosceles right triangle is bounded by y equals square root of cosine x. So the height and the width is all square root of cosine x. And if you want to find the area of this triangle, it will be 1 over 2 square root of cosine x times square root of cosine x, which is just cosine x over 2. And then we are given that it's and the x-axis on negative pi over 2 to pi over 2. So the volume is cosine x over 2, which is area, dx, negative pi over 2 to pi over 2. So 1 over 2 cosine x dx is same as sine x over 2, and integrated from pi over 2 to negative pi over 2. Sine x pi over 2, sine x over 2 is sine pi over 2 over 2 minus sine negative pi over 2 over 2. So this is just becoming as 1 over 2 minus 1 over 2 minus 1, which is 1 over 2 plus 1 over 2, which is 1. So the answer is B. Okay, so the question asks find the formula for the volume of the following solid. Okay, so let's draw the solid first. Y equals square root of x, and then x-axis, x equals 1, y equals 1. Okay, and then let's look at the options. It all starts with 2 pi. This means it's a shell method. Good to know. And then it's revolving around the line y equals 1. If you remember the shell method is always parallel to the revolving line. So the thickness will be dy. So you cancel out all those options for dx, and then circle the dy's. Okay. And then let's find the radius and the height. Shell method is b equals 2 pi, radius, height, and then thickness. So in here, we want to find the radius. Radius is 1 minus y. So this much. We want to find this much. So r is 1 minus y. Okay, we have 1 minus y, so it's not e. And then we want to find the thickness. So thickness, not the thickness, height. We want to find the height. So height is this much. So when we want to find the height, we have to write in the y, like with respect to y. So we write y equals square root of x into x equals y squared. So this is this much is y squared, and the entire line is 1. So if you want to know this much, which is height will be then 1 minus y squared. So okay, so we have every component. So let's rewrite the equation. Then b equals 2 pi, b equals integral 2 pi 1 minus y r 1 minus y squared, height, and then thickness dy. And this is integrating from 0 to 1. So if you look at the options, then the only answer that works is A. So if you remember the arc length equation, the arc length equation is AB square root of 1 plus f prime of x squared dx. And we are given already the arc length equation, and we want to find the fx. So let's equal 1 plus f prime x squared equals 9x to the 4th plus 6x squared plus 2. Then f prime x squared would be same as 9x4 plus 6x squared plus 1. F prime x squared this is just the squared. So 3x squared plus 1 squared. So then f prime x will be equal to 3x squared plus 1. And then if you want to find the fx, the original function, we integrate f prime x. So integrating 3x squared plus 1, this will give you x cubed plus x, which is E. So this question is find the area of the surface obtained by rotating the curve from 0 to 3/1/4 power. Okay, so let's draw the curve. Y equals x cubed over 3, and it's 0 to 3/1/4 power, like this. And if you remember the surface area equation, it's 2 pi fx square root of m plus 5 f prime x squared dx a to the b. And we are given the a to the b is 0 to 3/1/4. And then we are given fx is already x cubed over 3. F prime x will be just an x squared. So we can rewrite the surface area equation as 2 pi 0 to 3/1/4 fx x cubed over 3 square root of m plus f prime x squared, so x to the 4th power dx. U substitution, u equals 1 plus x to the 4th, du would be 4x cubed dx. X cubed dx would be du over 4, and x cubed over x dx is du over 12, because that's what we have in our integrand. And you rewrite our interval, then 1 plus 0 to the 4 is just 1, and 1 plus 3/1/4. 4 would be just 1 plus 3, because 1/4 and 4 will cancel out, and it will be 4. So the surface and area integral equation would be 2 pi 1 to 4 du over 12 square root of u. So you can take it out 1 over 12 out, so surface area will be pi over 6 1 to 4 u 1/2 du. Pi over 6 u 3 over 2 2 over 3 1 to 4. So this will just become pi over 9, because 2 over 3 can cancel out with if you multiply pi over 6, and 2 over 3, 2 and 6, well, 2 will cancel out, and then 3 will left, so pi over 9. So 4, 3 over 2 power minus 1 over 3 2 power, which is pi over 9, 2 squared, 3 over 2 minus 1, which is pi over 9, 8 minus 1, so 7 pi over 9. So the answer is C. So, okay, this question asks find the volume of the solid generated by those curves. Let's draw the curve. Y equals x and y equals x plus 2. So, and then it's x0, x equals 2. So this much area. So if we have those kind of region, we are going to use the washer method. So the washer method is b equals pi outer radius squared minus inner radius squared, and then dx from a to b. So in here, our outer radius would be this line. So outer radius would be x plus 2, and our inner radius would be this line. Inner radius would be x. So if you write the equation, the volume would be 0 to 2, because it's rotating from 0 to 2. 0 to 2 pi x plus 2 squared minus x squared dx. You can take out the pi out. 0 to 2 x squared plus 4x plus 4 minus x squared dx. And this is just pi 0 to 2. X squared cancels out, 4x plus 4 dx. And then if you integrate it, it will be just 2x squared plus 4x, 0 to 2 pi. So then pi times 2 times 2 squared plus 4 times 2, which is just 16 pi. So the answer is F. Okay. So this question asks a force of 40 N is holding a spring 0.1 meter from its equilibrium position and how much work. So the work equation is A to the B, force equation, integrating. So we want to find the force equation first. And the force equation is K constant times X, the length. So we are given the force is 40 N. Force is 40 N. And K times, we don't know K, and it's holding a spring of 0.1 meters, so the length is 0.1. So K is 40 over 0.1, K is 400. So we know that force equation is 400x. Now we want to find the work, so 400x dx, and it's stretching from an additional 0.1 meter. So it's already at 0.1 and it's stretching to 0.2. So 0.1 to 0.2, 400x dx integrating. So 200x squared, 0.1, 0.2 integration. So 200, 0.2 squared minus 200, 0.1 squared. This will just give you 8 minus 2, so 6n. So the answer is C.